Welcome back, Algebra 2 students, to another Regents review video. This is the Algebra 2 Common Core exam for the August 2016 administration. This is going to be a long video. I'm sorry. These are going to be the solutions to parts 2 through 4. Yes, the short answer questions for Algebra 2 is really in-depth. I need to take a little bit to explain it. You need to write a lot of words, a lot of math involved, and let's just begin soon, I guess. Let me just tell you a few things first. As usual, before we begin, do not take these answers and put them on a piece of paper and cheat. That is not ethical. I don't like it. I don't like cheaters. I really don't. So please, attempt the problems by yourself. I know they're hard. I do. And that just should tell you even more. If you don't know it now, and if you use my videos to cheat, you're not going to do well in the exam. So make sure that you try the problems by yourself first. Hit that subscribe button down below. Consider becoming a patron on my Patreon page. I thank you for your support if you do or decide to do it. And visit my website at www.nysmathregentsprep.com for more content in Algebra 2. And I use the TI Inspire CX calculator, very powerful tool. You can find the link on my website, and it links you right to Amazon. Without further ado, we're jumping right to the part 2s of this exam. Here we go. The volume of air in a person's lungs as the person breathes in and out can be modeled by a sine graph. A scientist is studying the differences in the volume for people at rest compared to the people told to take a deep breath. When examining the graphs, should the scientist focus on the amplitude, the period, or the midline, and explain your choice? So this is definitely a kind of a challenging part 2 question, in my opinion. So you have to understand that volume means the amount of space in the lung. So they are taking a deep breath and they're breathing in and out, okay? So, of course, it's modeled by a sine function because they're breathing in and out, right? In, out, in, out, in, out, in, out. So, this is the sine graph. So this is breathing in over, this is breathing in over here, out, in, out, in, out, in, out. Now, the reason why the in is up top is because the volume expands. Then the volume contracts when you're breathing. So how do you figure out how much volume is in your lung? Are you looking at the amplitude, the period, or the midline? Well, the midline is right here. Does that tell you about anything with the volume? It does not. Is it the period? Well, the period is the amount of times the cycles occur in 2 pi radians. It does not matter what the period is. The period just tells you how many times you breathe. Your answer is the amplitude. The amplitude tells you the height of the graph. That's what we want. We want the height of the graph. So your answer is the following. The answer is amplitude because the height of the graph represents the volume of the air. Volume of the air. And that's it. You're done with that question. Moving on to number 26. Explain how 3 raised to the 1/5 raised to the 2nd power can be written as the equivalent radical expression, the 5th root of 9. Okay, so let's talk about a couple things. 3 raised to the 1/5 squared. So the first thing that I want you to do is I want you to actually show that this equals this by using actual math. Then you have to explain it in words. So let's go ahead and solve it using mathematics first. This is your power to power rule. We can multiply these 2 exponents. When you multiply these 2 exponents, we get 3 raised to the 2/5 power. Okay? 1/5 times 2 is just 2/5. Now, remember your concept of plant over root. Here's your plant. Here's your root. Like that. So the top is your plant or your power for the p, and this down here is your root. Now remember how a radical looks. It is it's the root with a radical sign. This is your radicand, the n, raised to the superpower of p. This is how a radical should look. So what we're going to do is we're going to take these numbers and put them into this form. Okay? So all we need to do is take 3, put it underneath the radical, that's your radicand, raise it to the second power, and your root is 5 in the little cup over there. So what's going to happen is 3 squared is 9. So it's the 5th root of 9. Isn't that the same thing as what they're asking us to find? Yes, it is. Perfect, we got it. So what we need to do now, folks, is explain what we just did. And this is definitely a harder part of math, to explain why you did it. So here's what I wrote, okay? A fractional exponent can be multiplied. That's called your power to power rule up there that I just did. So it can be multiplied using the power to power rule of exponents. Okay? This fraction that you get, this fraction, can then be rewritten as a radical. That doesn't look like an R. A radical with the denominator as the index and the numerator as the power. Okay, so it's just, again, you could write this down as your explanation. It's the index, the square root. This is your radicand raised to the superpower. Again, that I is your index. You could also call that R for your root. That's your radicand. And that's your power. Ladies and gentlemen, that is how I explain my answer. You could write anything in that form. That's probably the best answer that you could possibly write. Okay, moving on to number 27. Simplify xi times I minus 7i squared, where I is the imaginary unit. So, don't forget that you need to use PEMDAS, okay? Don't forget your rules of PEMDAS. We need to apply the exponent first. You can't distribute that. No, can't distribute that. We need to FOIL this first, then distribute. So we get xi, in parentheses, y minus 7i. I minus 7i. FOIL it out. We get I squared minus 7i squared minus 7i squared plus 49i squared. And you're multiplying by xi in the front. We're going to combine these over here. Actually, nope, not even. We could actually substitute in for what I squared is. I squared, ladies and gentlemen, I squared is equal to the number -1. And if you don't know what that or how I got that, plug it into your calculator. I promise you it will give you the answer. So we get xi times, let's see, we get -1 minus 7 times -1 minus 7 times -1 plus 49 times -1. So we get xi, in parentheses, this gives us -1 plus 7 minus 49. Inside these parentheses, this gives you a value of 36, so xi times -36. Xi times -36, ladies and gentlemen, your answer is -36 xi. That's your answer. Done. Not too bad of a question, just basic simplification of your powers of I. There you go. Moving on to number 28. Using the identity sine square theta plus cosine square theta equals 1, find the value of tan theta to the nearest hundredth if cosine theta is -0.7 and theta is in quadrant 2. So first and foremost, I want to talk about a couple things. Tangent. You should remember from this here that tangent is the same thing as saying sine of theta over cosine theta. If you don't know it, devote it to memory. That is also on the facts you must know called for the Regents exam for Algebra 2. Okay? And quadrant 2 means that tangent is negative. So you should be thinking right now that all students take calculus. Your answer must be negative. It must be negative because it's in quadrant 2. They're asking you for the value of tangent. Your answer has to be negative because tangent is negative in quadrant 2. So let's go ahead and use this identity to solve for it. Sine squared theta plus cosine squared theta equals 1. Okay, let's do it. So what we're going to do first is we're going to plug in negative 0.7 into cosine because they tell you that cosine theta is negative 0.7. But we have a problem here, ladies and gentlemen. This is cosine squared theta. Well, we could actually rewrite this. Don't forget that sine squared theta plus cosine squared theta could be rewritten in parentheses as sine of theta squared plus cosine of theta squared equals 1. I don't know who decided to write it like this. I swear, I don't know who came up with that notation. I would love to know why they decided to screw with kids' brains, but it could be rewritten as this. Well, now it's just substitution. Cosine of theta is negative 0.7. Plug it in. So we have sine theta quantity squared plus negative 0.7 quantity squared equals 1. So now let's continue to solve. Negative 0.7 squared is 0.49. So we have sine theta squared plus 0.49 equals 1. Subtract the 0.49 on both sides. So we have sine theta quantity squared equals 0.51. So now all you do is you take the square root of both sides to get rid of that sine squared because we want sine, remember? So you got the sine of theta. Now we just need to take the square root of 0.51. So the square root of 0.51, that gives you 0.714. Okay, I'm going to write that whole decimal. Get ready, peoples. 0.71414284284. Okay? So now we have this, right? And we have the cosine. Let's find tangent. The tangent of theta is equal to sine theta over cosine theta. We have sine of theta. It's that disgusting number. It's 0.71414284284 divided by negative 0.7. When you type that into your calculator, you get an answer of negative 1.02. Rounded to the nearest hundredth, your answer is negative 1.02. And just to make sure, ladies and gentlemen, is your answer negative like I said? Yeah, it's negative. So we know for sure that we got that question right. So your answer, tan of theta, is equal to negative 1.02. That is the answer to question number 28. Moving on to 29. Okay, we got a very wordy part 2. Here we go. Very wordy. It says here, Elizabeth waited for 6 minutes at the drive-thru at her favorite fast food restaurant the last time she visited. She was upset about having to wait that long and notify the manager. I would be too. If I waited 6 minutes for a Big Mac, I would be very upset. The manager assured that her experience was very unusual and that it would not happen again. A study of customers commissioned by this restaurant found an approximately normal distribution of results. The mean wait time was 226 seconds and the standard deviation was 38 seconds. Given these data and using the 95% confidence level, was Elizabeth's wait time unusual? Justify your answer. So they're doing this question a lot. What they want you to do, and this is how we do it. What they want you to do is they want the mean to be 226. We know that. They tell you that the mean is 226 seconds. Now, I'm actually going to convert this into minutes. You just have to divide by 60 to convert it to minutes. So this is, or 3.77 minutes, okay? Just in case you wanted it in minutes. So, what they want you to understand is this. 95% confidence level means that you're using 2 standard deviations to the left and to the right of the mean. So we're looking for the mean plus or minus 2 standard deviations. That's our goal. That's what we're looking for. Okay? So here we go. To figure out the interval of the 95% confidence level, we need to take the mean. Let's see. We take the mean, 226, and we're going to subtract 2 times the standard deviation of 30. Is it 38 seconds? Where does it say? The standard deviation is 38 seconds. Give me 1 second here. And the standard deviation was 38 seconds. So here, all right. So here's the thing. What we're gonna do. Actually, did they tell you that 20 and the standard deviation was 38 seconds? So here's the thing. The interval. Let me back it up here. The interval is 188 seconds to 264 seconds. That is your interval in this case. So how do we figure that out? Okay. What we're going to do is we're going to take 226 seconds and we're going to add on a standard deviation. And we are going to have 226 seconds and subtract some sort of standard deviation. What I'm confused about with, and just because I'm slowing down here, what I don't enjoy is that they tell us 95% confidence level. So shouldn't it be plus minus 2 standard deviations? According to my answer key, I did not multiply by 2. And I wonder if I did it wrong on my answer key. And I apologize. Unfortunately, I'm not going to crop this out just because this video has to keep moving. Let me go to an answer key real quick that I have on my other computer. No, the interval is not 188 to 26. No. I forgot to multiply on my answer key. Yeah, I'm not crazy. I need to take 38 seconds and I need to multiply it by 2. So we're adding on 76 seconds. So we're adding on 76 seconds and we are subtracting 76 seconds. My apologies. So the interval is 150 to 302 seconds. So this is 150 seconds to 302 seconds. I need to fix that later. Okay. So we got that, right? That's good. My apologies for that. So now it says, what's her wait time unusual? Well, and the reason why I converted into minutes first is they tell you that it's 6 minutes. So is 6 minutes unusual? 6 minutes, when you convert it into seconds, you just multiply this by 60. That is 360 seconds. Well, the interval is from 150 to 302. So the answer is, yeah, it's unusual. So we're going to say the conclusion. The conclusion. Using a 95% confidence level. Oops, need the 5. 95% confidence level. The mean plus or minus 2 standard deviations is a usual wait time interval. Elizabeth waited 6 minutes or 360 seconds. This is unusual, as this time lies outside of the interval. So absolutely, it is unusual that she waited for that length of time. All right, so that's your answer. I apologize for the confusion before. I don't know why I forgot to multiply by 2 on my key, which I usually, I do the answer key just so the video can move a little bit quicker by me not typing a whole bunch of numbers into the calculator. So number 30, the x value of which function's x-intercept is larger, f or h. Justify your answer. So we're basically, it's telling you the x-intercept. Well, ladies and gentlemen, the x-intercept is where y equals 0. So what you're doing is you're letting the y value equal 0. Okay? Well, take a look here on the table. Where the y value is 0, the x-intercept is 2. So this has an x-intercept of 2. The x-intercept over here, well, we're just going to let this equal 0. 0 equals the log of x minus 4. Okay? Now, all logarithms, you should know, has a base of 10 unless otherwise noted. In order to solve for x, what you're going to do is you're going to raise both sides to 10. Or, another way to do it, and I teach it like this. I call this the logy loop. Okay? Logy loop, I know. So I'm going to take 10, raise it to the 0 power, and set it equal to x minus 4. 10 raised to 0 power equals x minus 4. What I just did is I converted from logarithmic form to exponential form. Well, anything raised to 0 power is 1. That equals x minus 4. Add that 4 on both sides, and we get 5 equals x. So that's your x-intercept for this one, and the other one is 2. Well, which one has a greater x-intercept? Well, f of x has a greater x-intercept because 5 is greater than 2. Ka-ching. You're done. Pretty simple stuff. That is your answer. Moving on to question number 31. Here we go. The distance needed to stop a car after applying the brakes varies directly with the square of the car's speed. The table below shows stopping distances for various speeds. Determine the average rate of change in braking distance in feet per miles per hour between one car traveling at 50 and one car traveling at 70. So here's what you're doing. You're calculating the slope between 50 and 70 miles an hour. So we're looking here and we're looking here. So all you need to do is the change in y over the change in x. This is your x, that's your y. So we have 306 306.25 minus 156.25 divided by 70 minus 50. We get, when you type this into your calculator, you get 7.5 feet per miles per hour. That is your answer. That is the average rate of change. Okay? So that's the first part of the question. Now for the second part of the question, it says explain what this rate of change means as it relates to the braking distance. So all you got to say is this rate, let me make this bigger, this rate of change means that for every 1 mile per hour above 50 miles per hour, the braking distance increases on average by about 7.5 feet. And that is it. That's how you do it. Not too bad of an explanation. Could have been worse. All right, moving on to probability here. Number 32. Given. All right, so we're given events A and B such that the probability of A equals 0.6 and the probability of B equals 0.5 and the probability of A union B is equal to 0.8. Determine whether A and B are independent or dependent. So you're using what's called the test for independence. So here's the test for independence, and here's what it says. The test for independence. It says, if the probability of A given B, or A intersection B, if this equals the probability of A times the probability of B, then the events are independent of each other. So here's what we got so far. We are given that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. So what I just did is I just wrote out this formula in terms of this. So you need to know that the test for independence is this, and the union set can be written as this form, okay? So the probability of A union B is 0.8. They tell us that in the given information. The probability of A is 0.6. The probability of B is 0.5. We need to figure out this. What's the probability of A intersection B? Okay, let's do it. So, all we need to do is combine like terms. We get 0.8 equals 0.11 minus the probability of A, B. So I'm going to subtract that 0.11. We get negative 0.3 is equal to negative P AB. Now we just divide by that negative. So P A intersection B is positive 0.3. So now what we got to do is we got to test for independence. Oh, I'm sorry. Did I keep saying intersection? I meant given B. So A given B. So all we need to do is take this information and plug it into the formula that we got up here. So here we go. The test for independence. The test for independence. So the probability of A given B, does that equal the probability of A times the probability of B? Well, they tell us that the probability of A is 0.6. The probability of B is 0.5. And we got this to be 0.3. What is 0.6 times 0.5? 0.3 is equal to 0.3. Yeah. They're the same number. So therefore, your answer is events are independent because those two numbers are equal to each other. And that's how you do that question. Not too bad of a probability question. Again, could have been a lot worse. All right, moving on to question number 33, onto the part 3s. Here we go. Find algebraically the zeros for P of x equals x to the third plus x squared minus 4x minus 4. So what you need to do is do some group factoring. Okay, here we go. Group factor this, group factor this. Take out a GCF of the first one. The GCF of the first binomial is x squared. You're left with x plus 1. For the second one, take out a negative 4. You're left with x plus 1. And this is all equal to P of x. But now we got to solve for the zeros, meaning that you got to set this whole thing equal to 0. But before that, we need to combine the x squared and the negative 4. So we get x squared minus 4 times x plus 1. And we just set it equal to 0. Let's solve for it. We get x plus 2, x minus 2. I got that by using the difference of two perfect squares. And then x plus 1 carries along for the ride. Set it equal to 0. Do your t-chart. You're just taking the opposite of what the factors are. So this is x equals negative 2, x equals positive 2, and x equals negative 1. Ladies and gentlemen, these are your zeros. X is equal to the swirly bracket of negative 1 and plus and minus 2. And that's your answer. Okay, not too bad. Not too bad. Now, on the set of axes below, just graph it. So, what I highly recommend that you do is you actually graph this into your graphing calculator and be as accurate as humanly possible. But we know the roots already. We know it's negative 2, negative 1, and 2. What I want to do is I want to be incredibly accurate. So what I'm going to do is I'm going to set up a table of values. Okay? Yeah. So negative 3, negative 2, negative 1, then 1, 2, 3. All right? This is called a selected table of values. I'm just picking numbers that I think are appropriate. 0, 0, negative 6, 0, 20. So we knew that these were going to be zeros because we just found those zeros, right? So if we go down to negative 3, that equals negative 10. 1 equals negative 6. And the 3 equals way up there. So basically what we're doing is we're drawing, I'm going to draw this very carefully, slowly. We're drawing from here We have a little increase there. Go down and then up. Knew that was going to mess up. Go down and then up like that. And that, ladies and gentlemen, is P of X. That's how you graph it. Pretty simple stuff. 34. One of the medical uses of iodine-131, a radioactive isotope of iodine, is to enhance X-ray images. The half-life of I-131 is approximately 8.02 days. A patient is injected with 20 milligrams of I-131. Determine to the nearest day the amount of time needed before the amount of I-131 in the patient's body is approximately 7 milligrams. Okay, here we go. You need to know it. A of t equals the principal times 1 plus or minus a rate raised to the t power. This is exponential growth or decay. We are doing, looks like decay, because we're trying to find how much time is needed to leave the body. Well, determines the nearest day the amount of time needed before the amount of I-131 in the patient's body. Okay, yeah, so we're going down. Because they're given 20, we want it down to 7. So, here's the thing. We're actually given A of t. A of t is 7 milligrams. That's what we want it to be. Your principal, which is the amount of milligrams given to the patient, is 20 milligrams. The rate, it is decreasing by, they tell us, where is it? Okay. They actually don't tell us the percent, but you need to know that half-life means 50% decrease, which is equal to 0.5. And the t, all right, this is the tricky one. The amount of time is actually t divided by 8.02, because it's saying here that the half-life is approximately 8.02 days. So what we're doing is we're taking the amount of time and dividing it by the 8.02 days to express it to the nearest day. Okay? So I'm going to plug in all my information. We're trying to solve for, what are we trying to solve for? Yeah, we're trying to solve for little t over here. So let's go and plug it in. So we get 7 equals 20 times 0.5 raised to the t divided by 8.02. Remember that 0.5 is a 50% decrease, so it's 1 minus 0.5 or 0.5. Now let's divide by that 20. We get 720 equals 0.5 to the t over 8.02. What you're now going to do is you're going to move it downwards, because we got to solve for t. We can't solve for t in an exponential position, so we got to move it down. So I'm going to move it down. Once we do that, we have to take the log of both sides. So log of 720 equals t divided by 8.02 log of 0.5. Okay? Now what we're going to do is we're going to multiply by the reciprocal on the right-hand side. The reciprocal is, you're multiplying by 8.02 divided by the log of 0.5. Because, again, we want to solve for that t. So these cancel. I'm going to multiply on this side over here. 8.02 divided by the log of 0.5. Okay. So when we get this, we get t equals, let's go ahead and plug this in. Go to your calculator. Control division. 8.02 divided by the log of 0.5. 0.5 times the log of 7 over 20. And we get 12.15. But it says round it to the nearest day, so it's 12 days. T equals 12 days. That's how much time needs to pass to get the next round. And that's how you do that question. All right, moving on to number 35. Solve the equation, the square root of 2x minus 7 plus x equals 5, algebraically, and justify the solution set. So, we got to isolate that square root term. So the first thing that I'm going to do is I need to move that x to the right-hand side. So we got 5 minus x, right? So now let's square both sides. We get 2x minus 7 equals 5 minus x, 5 minus x. Remember, if you have a square, you can write it twice. Now we could FOIL this. we get 2x minus 7 equals 25 minus 10x plus x squared. Now what we're going to do is we're going to move everything to one side and set it equal to 0. Subtract the 2x and add the 7. Subtract the 2x and add the 7. So we get x squared minus 12x plus 32. Set that equal to 0 and solve by using the AM method of factoring. What adds to negative 12 and multiplies to give you 32? Well, that number, or those numbers I should say, are x minus 8 and x minus 4. That'll equal 0. T-bar it up. We get x equals 8, x equals 4. Okay? Now we have those numbers. Now we need to check, because it says, and justify the solution set. Justify meaning you need to check your solutions. And if you don't get credit. So we need to check. We need to check x equals 8 first, and then we need to check x equals 4. So if I take 8 and plug it back into the original equation, we get the square root of 2 times 8 minus 7 plus 8. Does that equal 5? So this is the square root. 8 times 2 is 16 minus 7 plus 8 equals 5, right? The square root of 16 minus 7, that's the square root of 9 plus 8 equals 5. The square root of 9 is 3 plus 8 equals 5. 8, 9, 10, 11. Does 11 equal 5? It does not. So that 8 rejects. Okay? Now let's go ahead and try x equals 4. X equals 4. So I'm going to plug it in. We get the square root of 2 times 4 minus 7 plus 4 equals 5. The square root of 8 minus 7 plus 4 equals 5. That is 1 plus 4 equals 5. Does 5 equal 5? And yes, it does. So therefore, x equals 4 is the only answer that satisfies this equation. And that's how you do that question. All right, moving on. We're almost done with this exam. Almost done. We've got another statistics question going on here. And this was a 2-pager statistics question. A lot of stuff here. Let's take it slow. Ava designed an experiment to determine the effect of a new energy drink on a group of 20 volunteer students. 10 students were randomly selected to form group 1, while the remaining 10 made up group 2. Each student in group 1 drank 1 energy drink, and each student in group 2 drank 1 cola drink. 10 minutes later, their times were recorded for reading the same paragraph of a novel. The results of the experiment are shown below. So just to keep yourselves thinking, group 1, remember, group 1 is the energy drink, okay? This is the energy drink, and this is the soda or the cola, okay? So as you can see, the general gist of this, the mean for the energy drink is less than the mean of the cola drink, meaning that the energy drink might have some impact on reading speed. Just think of that while you're reading this. Now, Ava thinks drinking energy drinks makes students read faster. Using information from the experimental design or the results, explain why Ava's hypothesis might be incorrect. So there are many different answers that you could use to get this question right. The first thing is this. She only volunteered or tested 20 volunteer students. Now, in order to show statistical relevance, you need a bigger sample size. You cannot have just 20 people and call it a day and say, all right, clearly energy drinks have an impact on reading speed. You need to survey like a couple hundred people to get an accurate representation of energy drinks. So you could say the following. You could say that the sample size is very small. Okay? There are only 10 students per group. So that's one thing to say. Okay? Or you could say this, okay? It then says 10 minutes later. But what if, ladies and gentlemen, that cola, see, energy drinks have quick boosts of energy. Coca-Cola or soda has sugar. Your body needs to digest sugar and then you have a sugar rush. Some of you do, maybe. So what I also said is this. She can't be sure 10 minutes is enough time. 10 minutes is enough time for the different drinks to have an impact on speed. Sorry, on reading speed. So any of these answers would be acceptable because both of them show a flaw in her hypothesis. The sample size is too small. You need a lot more people. And how does she know scientifically that Coca-Cola could kick in maybe a little bit later, maybe 20 minutes later, as opposed to the energy drink? Maybe they'll read faster 20 minutes from now. Who knows? So that's what makes her hypothesis incorrect. And you just need to think like that in order to get that question correct. Okay? Now, moving on to this over here. Now, ooh, God almighty, we got this stuff. Using the given results, Ava randomly mixes the 20 reading times, splits them into two groups of 10, and simulates the difference of the means 232 times. I hate when they do this, really, on the Regents. I hate when they take a real-life scenario, then they put it into some computer garbage. It's ridiculous. But anyway, Ava has decided that the difference in mean reading times is not an unusual occurrence. Support her decision using the results of the simulation. Explain your reasoning. Okay? So we actually need to go back for a second and analyze her data. The mean, ladies and gentlemen, the difference between the two means, is a difference of negative 1.4. If you just take 19.1 minus 17.7 or the vice versa, it's a difference of negative 1.4. Okay? So that's found by 17.7 minus 19.1. And that gives you the mean. Okay? So in this case, she's saying that the differences in mean reading times is not an unusual occurrence. Okay? So here's your answer explanation. In Ava's initial experiment, meaning what she just did with her 20 volunteers, in Ava's initial experiment, the differences, or the difference in the means of groups 1 and 2 was negative 1.4. The graph above shows that negative 1.4 is not so rare. So the difference is not an unusual occurrence. Look here, ladies and gentlemen. The mean of negative 1.4 is somewhere in this vicinity. That is not an unusual occurrence because there is something going on here. If it was all the way over here, then yeah, there's nothing over there. It would be a unusual occurrence. But it's not unusual because it's clearly showed in the simulated differences on the graph. It's around here somewhere. So we know that it is not an unusual occurrence. Honestly, I think that's such a stupid... I think these are the stupidest questions ever given on a Regents exam. Whoever writes this stuff should be fired because I don't like the way that these things are worded. Anyway, last question of the exam, then you could move on to some more fun things other than math, unless you're studying before your Regents, which you need to do more work if you're studying before your Regents. 37 says, Seth's parents gave him $5,000 to invest for his 16th birthday. He is considering two investment options. Option A will pay him 4.5% interest compounded annually, while option B will pay him 4.6% compounded quarterly. Write a function of option A and option B that calculates the value of each account after n years. I think that they were nasty, because they usually give you the formula that you need to use. You had to know, ladies and gentlemen, that you have to know, okay, well, you have to know that a of t equals p times 1 plus or minus r raised to the t power. You know that from memorization. So it's easier to find the option A1. The option A1 is a of t equals the initial amount of 5,000 times 1 plus 0.045 raised to the n power, because it's 4.5% interest. You're getting money from the bank, so interest is increasing the value of your account. This is an easy equation to calculate. And it's compounded annually, so it's just once a year. Then we have a problem here. For the next one, it says compounded quarterly. I'm telling you, this one was a little trickier to find. You had to know the formula, p times 1 plus or minus r over k raised to the kt power. Let me write that for you. B of t is the principal times 1 plus r over k raised to the kt power. The r still means the rate, the p still means the principal, but this time the k means the amount of compounds per year, and t is in time. So b of n is actually 5,000 times 1 plus the rate, which is 0.046, divided by the amount of compounds. Compounded quarterly, there's 4 quarters in a year, so they're compounding it by 4. That's 4 right there. Raised to the 4n. Okay? So these, ladies and gentlemen, are your 2 formulas that you need to get this question right. And that's how you do that part. Then it says, for the next one, Seth plans to use the money after he graduates from college in 6 years. Determine how much more money option B will earn than option A to the nearest cent. So here's what you're doing. You're taking this information over here, and you're plugging it in 6 to both of them. So you're plugging in into B first. So B of 6 is equal to 5,000 times 1 plus 0.046 divided by 4 raised to the 4 times 6 power. You get an answer of 6,578.87, rounded to the nearest cent. Then you have A of 6. Well, A of 6 is 5,000 times 1 plus 0.045 to the sixth power. I can't say that word, sixth power. When you type this into your calculator, you get $6,511.30. Not that big of a difference, but there is a difference. You just subtract these two numbers. Oops. $6,000. Sorry, that... I don't know where that 5 went. That should be a 5, folks. 6,511.30. And we're just subtracting this. 6,511.30. When you subtract it, you get a saved option of 67.57. That's how much money... Sorry, that's how much more money you could earn from option B than from option A. Okay, there you go. $67.57. Now, for the next one, algebraically determine to the nearest tenth of a year how long it would take for option B to double Seth's investment. Doubling. So Seth's investment, initial investment, was $5,000. If he wants it to double, he wants it now to be $10,000. So what we're going to do is we are going to use option B. We're going to use option B to figure this out. So 10,000 equals 5,000 times 1 plus 0.046 divided by 4 raised to the 4n power. We want to find out to the nearest tenth of a year how long it would take for this to double. So the golden egg, what we're trying to find here is we're trying to find the letter n. Okay? In order to do that, we need to divide by 5,000 first. Divide by 5,000. Divide by 5,000. We get 2 equals 1 plus 0.046 divided by 4 raised to the 4n power. We're going to move this down in the front. So we get 2 is equal to 4n. Now, the minute you move an exponent down, you need to write the word log of 1 plus 0.046 divided by 4. And what you once you do log to one side, you must do to the other side of the equation. So now, to solve for n, you just divide by 4 log of 1 plus 0.046 all over 4, and do the same thing over here. It's a lot of math. 4's cancel, all the logs cancel, you get n. I'm not going to type it into the calculator because I'm lazy, but if you type it into your calculator, you get n is, it says to the nearest tenth of a year, n is equal to 15.2 years. And that is the answer to that question. I hope that this helped you. That is the end of this exam, or the video in this case. Make sure that you hit that subscribe button down below. Consider becoming a patron on my Patreon page, and visit my website at www.nysmathregionsprep.com for more math content in Algebra 2 and future math subjects. And I hope to see you soon.